Fourier series, right? How to obtain the Fourier series expansion based on the function given. If you have f(x) is given, you identify your L, you identify your T and the types of function, and then you just need to identify which formula or which function that you have to use in order to expand that function to the Fourier series expansion. So those we have done there. Alright, the given range is from minus L to L, remember? Okay, even though it is a piecewise function, let's say it is from minus pi to 0 and then 0 to pi, right? But here, the given function is still in from minus L to L. So this is for full range expansion. So what we have done previously, it is about full range expansion. So as for today, we just want to focus on half range expansion. So instead of, in terms of half range, instead of from minus L to L for full range, okay, so now we have half range. Either it can be from minus L to 0 or from 0 to L. Only one of these. Okay? Either it is from minus L to 0 or 0 to L for half range expansion. Alright, so in this section, we will address the following question. Can we find a Fourier series of a finite interval? So this is finite interval. As for now, we know a periodic function demands an infinite interval. Okay, as you can see, if you are given in terms of t, the function is repeatedly about t value, right? For periodic function. Okay, so the answer is yes, but we have to convert the non-periodic function into a periodic function. So this can be accomplished by extending the definition of the function in equation to the interval. So we need to do some extension to the function, okay, so that the extended function is either even if we want a cosine or odd if we want a sine. So for this half range expansion, we only will have either Fourier cosine or Fourier sine. So for Fourier cosine, the function need to be odd. For Fourier sine, the function need to be even. So for this case, okay, this is can you hear me?
Ya, dokter.
Yes, Doctor.
All right, can you see the screen? Sorry, I was disconnected. Where was I? What was my last word before?
cosine series is for odd.
Okay, this one. All right, so let's take a look at this example again. Okay, now as you can see, for this function, the given range is from 0 to 1. So this is finite interval. So we want to have at least half range of this Fourier series of fx here. Okay, so how can you know that this is half range? You have take a look at the range. It's from 0 to 1. So from 0 to L. Now for this half range, it can either be Fourier cosine or Fourier sine. How can we extend the function to the series here, where we need to do some extension to the definition of the function? Okay, so in order to have Fourier cosine, so the function need to be odd. In order for the function to be Fourier sine series, the function need to be even. Okay, so now from this example, okay, you know that this is half range. And from this half range, you know that your L equals to 1. Okay, so for half range, there are only two cases that we need to consider. Is it Fourier cosine or Fourier sine? And this function can be both. How it can be both? By looking at the extension that we can do to the function. Okay, so we have fx equals to 1 minus x. Okay, so now let's try to plot. Okay, let's try to plot. Find the half range. Find the half range means it can either be Fourier cosine or Fourier sine. So let's start with how can this function be Fourier cosine first? Okay. So now let's plot the graph. Fx equals to 1 minus x from 0 to 1. So from 0 to 1, fx equals to 1 minus x. So this is 1 minus x. Okay, so now in order to have a Fourier cosine, the function need to be odd, right? Sorry, even function, right? Cosine is even, sorry, this one even, this one is odd. Okay, so in order to the function of x here to be a Fourier cosine, so the function need to be even function. So from this plotted graph, how can it be an even function? Okay, how can this function be an even function? What you have to do? How can you know that function is an even or not? Symmetry at y. So meaning that it should be extended to this. Now, as you can see, the graph is even, where it is symmetric about y-axis. Okay? And then if L equals to 1, now this is a periodic function already. Since we extend, then we have L equals to T over 2. L equals to 1, T equals to 2. So as you can see, T here equals to sorry. This is the original function, not the extended function. Okay, so now your t equals to 2, L equals to 1. So this is how we extend actually. So we extend the function by showing at the graph where this function should be even function, where we extend the graph to the left there so that it is symmetric at y-axis. Okay, so now this is now, as you can see, fx is even function. So when fx is even, then we can do a Fourier cosine, where Fourier cosine should be what? Fx equals to a naught over 2 plus summation an cos n cos n pi x over L. Okay, so you have to find what is your a naught and what is your an. Okay, now just find a naught and an. So your a naught should be 2 over L. L is 1 from 0 to 1. Fx is 1 minus x dx. So integrate this will give you 2, 0 to 1, 1 minus x dx. X minus x squared over 2, 0 to 1 will give you 1. How to know we want to do odd or even? Depends on the graph. Depends on the question. Let's say find the half range Fourier cosine. Okay, let's say the question asks you find the half range Fourier cosine. Then you have to extend up to even. Okay, let's say the question asks you find the half range Fourier sine. Then you need to extend the function to odd. Okay, if the question asks you find the half range Fourier series, then you need to do both cosine and sine. Okay, clear. So this is your A naught. And then an 2 over L is 2 from 0 to 1, 1 minus x cos n pi x over L. L is 1 x. So this one is a combination of 1 minus x and cos n pi x. So we can do integration by part. U equals to 1 minus x. Du equals to minus 1 dx. dv is cos n pi x with sine n pi x. Okay, so substitute here. Integrate this. This one is already integrate. Then we just need to apply the limit there. 1 minus 1, 0. So 0 minus 1 minus 0, 1. Sine 0. Cos n pi times 1 over n pi squared minus cos 0 n pi squared. This is 0, negative cos n pi cos n pi is so this is your an. Okay, and then your Fourier series, just substitute. Fourier cosine series, A naught is 1 plus summation. An is 2 over n pi squared. Then you can put here, this is constant. L is 1. Okay, so this is cosine. Okay, the process is similar. Only the difference between the previous one, the full range, is we have to extend the function in terms of graph so that it can be even or odd. Depends on what series that you want to find. So now, let's take a look at the Fourier series, Fourier sine. Okay, so same process. Your function is 1 minus x from 0 to 1. So you need to plot. So from 0 to 1, this is the graph. Okay, so this is 1 minus x. So now we want to have a Fourier sine series where it should be, the function should be odd. So if the function should be odd, where should we extend this function so that the function is odd? Where? When the function is odd, it should be symmetric about the origin. So where should we extend? Then we just can extend to this. This is 0, this is minus 1. So we extend to, so that if this is your symmetrical line, then it is symmetric about origin. Is that clear? So now, as you can see, it is symmetric about the origin. Okay, then it is odd. Then we can do Fourier sine series. Okay, where for Fourier sine series, A naught and An is 0, then the series should be only the summation of Bn. Okay, is that clear or not? So you just have to find a Fourier sine series. So let's take a look at this passive question. As you can see, okay, you are given a half range, right? You are given a half range periodic function. So this is the function given. Then you need to sketch the graph of even extension. You need to sketch the graph of odd extension. So once you extend the graph, once you extend the function in terms of its graph, so that it can be even or odd, only then you know that Fourier series is cosine or sine. So let's say this graph, sketch the graph of even extension of fx in the interval. This one of odd extension in the interval. So when you know that it is even or odd, then you know that Fourier is in terms of cosine only or sine only. Okay, so that's why you have to know how can you extend the function graphically. Is that clear? So once it is extended, then you know that it is odd or even, then you know what Fourier series that you want to find. So for this case, this is odd. Now we just find the Fourier sine series where we have to find only Bn. Okay, where your Bn is equals to what? From 2 over L, L is 1, 0 to 1, fx is 1 minus x, same function, okay, sine n pi x over L, L is 1, dx. So again, integrate. All right, is that clear? For this case, try to find this Bn. You can get 2 over n pi. Then substitute. Try it. Same process with the previous one here. This one is 1 minus x cos n pi x. This one is 1 minus x sin n pi x. Same process. You do integration by part. You substitute the limit 1 by 1 there. Is that clear or not? This one, the partial here. Okay. So for this question, you know that this is half-range periodic function. Okay. Now we want to sketch the graph of even extension. So we want to extend this function to even extension in the interval and find its Fourier series. Of course, there has no mention about what types of Fourier series that you want to find. Okay, but now it is mentioned that sketch the graph. This is the function. Sketch the graph of even extension. So when it is extend to even function, then you know that we have to find Fourier cosine series. Sketch the graph of odd extension of fx in the interval and find its Fourier series. Then you know that this is odd, then the Fourier series that we can find here is Fourier sine series. So first plot this graph from fx pi minus x from 0 to pi. So from 0 to pi, so it is pi minus x. So this one should be like this, right? Where this is also pi. Okay. Now, from 0 to pi, this is pi minus x. And then from pi to 2 pi, it is 0. This one. So this is your graph. This is your graph. Now, this graph can be extended to a Fourier, to an even function if it's symmetric about y-axis in the interval of minus 4 pi to 6 pi. So you just have to plot the repeated graph from minus 4 pi to 6 pi. Okay, now let's plot from this 0 to 2 pi first. So if it is even, okay, if it is even, you know that it should be symmetric about y-axis. So this should be symmetrical here, right? Am I right? So this one is 0, negative pi, negative 2 pi. So what you need to do is to plot from the given range of this. Is it repeated to what? So now, as you can see, your t equals to what here? From here to here. What is your t there? Okay, so as you can see, the t is repeated from this one. From the starting point to the extended. So this is your starting point to the extended. Now this is your starting point. Now it is extended to where? This is the original graph, right? So it is extended to here. Right? This one also. So the key idea here is you need to know the graph is extended up to even or odd. So this is your t. To 0 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. This is your t. Then this one, negative 2, negative 3, negative 4 pi. So from negative 4 pi, now this is the given range from negative 4 pi to 6 pi, and this is the extended graph. Is that clear? Once you extend the graph, then you can say that this fx is extended to even function. So you show that this is even function. Okay, sketch the graph of even. So you have to show that this is even, and then you can obtain your Fourier cosine series. Is that clear or not? Clear, guys? This is your t. The original to the extended. So your t here is 4 pi. Okay. Why we have to extend in terms of graph? Because we want to find t. Why we want to find t? Because we want to find L. Because you cannot identify your L from here. Okay. For this piecewise function, you cannot find your L. Otherwise, for this case, for the previous example, it is easy because the given range is already in terms of half range for one function from 0 to L. You know that this is your L. But for this case, you are given in terms of piecewise, you need to plot, you need to extend, and then you can find your t, and then you can find your L, where L equals to what? Where L equals to t over 2, which is 2 pi. Okay, is that clear? Okay, anyone has question? So now, try to plot the odd extension there, so that it should be symmetric about the origin. And then identify the value of L and identify the value of T. Only then you can obtain your Fourier series. How to obtain? Of course, we still use the same formula. But for half range, you are instructed to, is it cosine or sine? So for cosine, find A0 and AN. For sine, only find BN. How to find? Same process with the previous one. Okay, this is half range. All right, the function is given, and you have to know that the function is actually not a periodic function. So how come we obtain the Fourier series? We have to have the periodic function. How can we obtain the periodic function? By extending the graph. Okay, previously, what we have done, in Fourier, you are given a function. And the function is already periodic function, where you just need to identify what is your L and T. And then you can just find the Fourier series by identifying that function is even or odd. Okay, and for half range, you can choose whether you need to extend to even or odd. Is that clear? Can you see the difference between the Fourier series that we have done previously and half range today? The difference is that. Clear not? Anyone has question? Repeat what? Repeat the different mean? Okay. All right. So, okay, again. For half range, okay, for half range, you are given a function. Okay. You are given a function. That function is initially not a periodic function. Okay, and you have to know, in order to construct a Fourier series, we should have a periodic function. That's why previously we learned about the periodic function first, and then even odd, and then you can find the series. All right, but for half range, the function given is not periodic, but it can be turned to periodic. As you can see, the non-periodic can be turned into periodic. How? How can we turn? By extend the function, okay? By extending the function here. So, Fourier half range initially is not given, initially the function is not a periodic function. So, we can change that periodic function to periodic function by doing some extension to the function, okay, where the function can be extended to cosine or sine. How? For cosine, we extend to even. For sine, we extend to sine. How can we extend? Basically based on the graph. Okay, we extend the function on the graph so that it is symmetric about y, or it is symmetric about origin. Once it is extended, only then you can obtain your value of L and T. Okay, for Fourier series, that we have done earlier, the given function is already periodic function. You just need to identify your L and T from the given function. Once you can have your L and T, what you need to do is to identify is it even, odd, or neither. Only then you can choose which formula, which Fourier series that you want to construct. Can you see the difference? Clear now? How to locate T? Okay, how to locate T after extension? You just, as you can see from here, you just take a look from the original point to the extended point. So this is your T. From this case, from the original point to the extended point. So this is your T. This is 1, this is 2. Okay, and then this one, from the original to here. From the original point to the extended point. So this is your T. Is that clear? So this is your T, then you can find your L. All right? So now, let's try to have some activity. Okay, try to sketch the graph of odd extension here. All right? And you can share your graph in WhatsApp group. I can see it here. Or you want to paste to the Jamboard or what? If you want, I can give you the link. WhatsApp group je lah. Senang. Okay, try it. Identify the extended graph for odd extension here. This is for even, this is for odd. So the problem for half range is only about the graph. Okay, correct graph, correct period, correct L, then of course, same process for Fourier series. Is it if it is cosine or sine? Okay, try. The original graph should be similar, but the difference is where it should be extended. So this is your original graph. Yes, Joe is correct. Okay, thank you, Joe. Join. Okay, let's discuss about this graph. Now you know that this is your original graph, right? This is your original graph. So in order to make sure it is symmetric about the origin, okay, and the reflected line should be here, okay, so you know that it should be extended to this. So the original graph is extended to this. Okay, as you can see, it is repeated, right? So it is repeated to this. First, you know that this graph is reflected here. Okay, but in order to make sure that it is reflected here, you need to know how it can be extended from the original graph. Is that clear? So from here, you can say that the value of t from the original point to the extended point here is same with the cosine. T is 4 pi. Sorry. So again, from here to here, okay, this one should be here. All right. Okay, clear not?
Yes, okay.
All right. So you have to make sure where should be it is reflected, and then how can you make sure that where it should be extended to make sure that it is reflected there. Okay, so you need to play around with the graph. Once you can show that function is now odd by showing through the graph, then you just can proceed with finding the Fourier sine series. That one is similar with the previous one that we have done. So the difference here is you need to plot the graph so that you can show that it is now extended to even or it is now extended to odd. Okay, clear or not? All right. So that's it for half range. So actually we have done with chapter 4 already. Anyone has question? So now from 1 to 10, where are you? Of course, for this chapter, you need to have a lot of exercise. Same with the previous chapter also, right?